As we were starting to think about this presentation, about this testing, the thing is that, as we've said it on the LinkedIn as well, the problem with testing is that usually people consider it quite similar to like visits of the dentist, because usually we all know that it's a very good idea to go to the dentist regularly because the pain in the future will be probably smaller, but we are still not doing it. And that's exactly the same thing with testing, because it's actually also painful for many of the developers. And the costs are considerably big for the customers who are paying for their time. But I hope that during this presentation, maybe because I'm a little bit, maybe so to say, test freak, we could be like, like the mom who's telling us that we have to go to the dentist. This presentation could be also something like, kind reminder that maybe it's a good idea to talk to our customers once more. So during this agenda, it's going to be quite, maybe it looks quite chaotic, but I would like to keep this idea of talking about tests maybe a little bit more complex, but rather scratching the surface rather than going into very much details. So I would start to talk about test types, and we are going to cover the idea of unit tests and integration tests combined, which is the very common framework. And it's appeared very, we can see it very often across different development programming languages and frameworks. So we will just cover how it actually works and the more abstract layer. And I would like to also then say how this concept manifests itself in Flutter. Also, I would just, as I said, scratch the surface of the test-driven development, as I'm a huge fan of it. And in my opinion, and this is something that I would like to maybe share with you, it's really worth to try doing TDD with Flutter, because Flutter is a very simple framework. It has a lot of potential risks, as it's really easy to mess your code, but it's also that easy that tests are also very easy and understandable. So it's not that difficult to be very sure that the test is a proper code that has to pass at some point. Also, I would like to give you some idea of how this testing environment for Flutter especially, and especially for Dot, which is the language which we're using for Flutter, and also some additional tools created especially for Flutter, works under the hood. So we will cover the basics of this environment, how it works, and so on. And the most important thing is that, as I said, the ground rule for this presentation is to give you some sort of security that this framework is well testable, so we can use it in production with a safe heart. And also, maybe it's a good idea to reconsider writing many more tests. The thing is that I've made this presentation like 2 times, and I also always ask people, like the audience, how many of you test the applications? I'm not sure if we have a tool here on the Zoom to do this, but usually when I ask how many people tested every single production application during the last year, it's like maybe 5 people on the audience. So it's not a big number. And it doesn't grow any better when you're asking about any production application. So that's maybe something to consider about the industry that we're working in, and maybe thinking about another ways of making these tests acceptable. What I prepared for the sake of this presentation is a very, very simple application in Dart. It's called A-Rudder because it was meant to show the air quality. But unfortunately, when I started to build the application, and when I was building the application, I realized that this API is paid. So instead, it's just showing the weather, which is also quite good. So if you don't hesitate to take a picture of the QR code from the guy with obviously Eastern European accent, then go ahead and take the picture. If not, you can basically go to the link and download the GitHub repository. It's open, free to use. And this is some sort of approach that I would like to introduce. So this is the application that I'm encouraging you to just take a look at, because it's more or less fully tested. It has few nice approaches. It's using some very common architecture, which is block, but it's using the custom implementation of it. So it's better and easier to understand how it works under the hood. So that's pretty much it. I'm not encouraging you to actually use it right now. Maybe this is a good thing to make, to look at this application a little bit later after this presentation. And the whole presentation will basically cover how those tests inside of this application were made. Okay, so let's start with the main thing, why you should test your code. And I think that we all feel it under the bone that without the tests, like it's like to have tests because you're much more sure about making any kind of changes. Maybe not like the simple screens, but let's imagine that you would like to make some refactor of a mechanism that is well spread across the whole application. For example, maintaining the session or something like this. Without tests, that could easily be run out and give you like the obvious answer that, okay, you didn't mess up the whole application. It's usually a little bit, stress out, and you'd probably like to ask your QA to do a full regression, for example. And you don't always have those kind of resources, so it's a good idea to have those tests. And the second thing that we are probably more or less aware of is that releasing the application onto the production which has bugs and fixing those bugs and the production could be a really huge roller coaster, and it's not a good idea. So whoever had this great weekend of 38-hour work will probably know actually what I'm talking about. And having a well-prepared testing suite is a great tool to prevent such situations to happen, because they will be able to catch those kind of regressions. Okay, so let's just say that we knew that, assume that we all know that tests are fun, that tests are good, but for some reason we're still not using them. And probably the answer is quite obvious. Usually it's like our customers' fault, as they're not willing to pay for that. But maybe we can also think that if we would have this kind of, we'll be sure that we are using the framework where the tests are not only easy to create and maintain, but they're also very valid tools for the quality, to make the quality of the application better. Maybe this is some sort of arguments that might change your mind. So I would like to maybe start with the introduction of what I've said, this unit test and integration test framework. So generally in a different testing environments, you can basically see this idea of unit tests and integration tests. So unit tests are meant to do exactly what they are saying in the name. They are testing units, like the basic small blocks that you have in your code. They could be some small classes with methods or functions, which in case of Dart that are like methods. And you would like to have some small objects, and you would like to be sure that those objects are working as expected. So let's imagine that we're, for example, having a wall inside of which we have a window. So we would like to be sure that the window that we've built inside of our code works as expected. So we can have the code as like example code as did here. So we are testing if we open the window, it's actually opened and it's no problem inside of it. Maybe if it handles some errors properly and so on. So if we have like a bunch of windows and we have another object that groups those windows, we are basically creating some integrations of those blocks. And that's pretty much what programming and objective language is. So we have some objects, we're creating those integrations, and those integrations have to be tested. So whichever test we are creating, despite the framework or the tools, that will just basically take a few objects that we've previously tested with our unit tests, and we'll check if those objects are integrating and cooperating with themselves properly. It's basically an integration test duty. So that's the example that we have here. We've created 2 windows, and we were expecting, if we open both of them, we are expecting both of them to be opened, like no one is stuck. And in order to make this, to justify this example, I would like to show you this. So this is a perfect example of a situation where we have 2 perfectly working windows, which definitely pass the unit tests, but we definitely failed to integrate them together. So that's the good clarification of this framework of unit tests and integration tests. And yeah, this is some sort of an abstract idea that's differently implemented in different frameworks, and we'll cover how it's done in the Flutter and in the next slides. But now I'd like to also skip to the idea of UI tests itself. UI tests are also meant to be very valid tools, but they're a little bit different from what I've said before. First of all, usually UI tests are not always created by developers themselves. Sometimes there are some separate groups of QA engineers who are creating those suites for themselves. And those tests are meant to be some sort of scripts that are using the application the same way that the user will do that. So it's some sort of a monkey that is clicking inside of our application. And the idea for those tests is that because they are run on the physical device or an emulated device, we can check if the application that we'll give to us customers has some junk code, for example, if it's meeting the requirements for the performance of the application. It can also check some high-level integrations. And we can also check some UI tests, some UI elements, if it works as expected, if the animations are correct, and so on and so on. And this is basically the idea of the testing framework in general, how it's usually done. And this is the very known picture of this triangle or the pyramid, which gives us the idea that we should have, first of all, the unit tests are the foundations of it. So we should have a lot of those unit tests. Usually it's said that it differs from the framework, but usually it's something around 70% of the whole number of tests. Then we are building integration tests based on the knowledge that those unit tests are passing. And then based on the knowledge that those integration tests are also passing, we can build those UI tests. It also gives us like different metaphors regarding the costs of those tests. Of course, UI tests are the most costly, the unit tests are the least costly, the time of running those tests, and so on, so on, so on. So this is the general abstraction for like different frameworks. And in Flutter, the situation is that we got a very nice and convenient tool, which is called Widget Tests, which is a perfect fit for creating those integration tests. To be honest, it doesn't like we can create integration tests and with the same tool that we're building those unit tests. It just regards if we are using some Flutter code as well. But the widget tests are the perfect tool for doing that. I would like to cover that later. But for now, I'd like to just say that the Flutter framework gives us a very nice and powerful tool for maintaining tests. I would like to go now to the idea of the testing environment, how it looks like, how it works under the hood, as I said before. So on the slide, you can see like the very basic test. That's how it will look like inside of our application. And the few things I would like you to keep track on, first of all, is that instead of, for example, Android framework or iOS framework, we are not creating some sort of class which is annotated some way. And those annotations are informing us if this if this method is a test or some setup. In Dart, because this is the testing framework for Dart itself, we are creating the application that will test our application. And this is this main method that is giving us, that is creating the application. This is like next the entry point. And inside of this main method, we are calling the method test, which just takes two arguments. The first is the name of the test, and the second is the callback. And the implementation of this method is, as you can see, it's built in the declarer method, the declarer class. I don't want to go much into details about that, but the most important thing is that the implementation of the method test uses method run zoned, which I'll cover a bit later. And this run zone method runs this await body, which is running the callback with pass to the argument test to the test method. So we are, this framework, testing framework, is just wrapping up our callbacks in this zones concept. And now I would like to make it a little bit more clear to you what those zones are. So zones are the very common concept for Dart. Basically, every time we are running Dart application, there is a zone created. And every single piece of the code in Dart works inside of some sort of a zone. And we can think about the zone as some sort of a box. So this will be the box that, as it's said by the definition, represents the dynamic extent of an asynchronous call. So whenever you're putting some sort of, it's quite academic, but we can simplify it that whenever we would like to put some sort of a method, that asynchronous method, inside of this box, every single process that is the task that is associated with execution of this asynchronous task will execute itself inside of this box. And this is great because if we would like to, for example, just dispose this box, we are not interested in this result, or this result crashes, or there's something different, like, for example, it works as expected, we can just take those results and dispose the box. And we don't have to be any kind of, we don't have to care if this implementation that run inside of this box interferes some way with the code from a different box. So this gives us a nice and stable environment across asynchronous calls. So you don't have to be you don't have to be scared that your test will, for example, messes up or put some data in some different thread, and those data will be consumed by another test. It won't do that. So this is a great, powerful tool which solves a lot of problems that will occur on, for example, Android framework. I would like to pause here for a second, and maybe you have some questions regarding this zone concept, because now I would like to clarify how it works. Do we have any questions? Okay, so either there is no one left.
Okay. There's no questions. You are so clear.
We don't have any questions. Maybe that's good. We'll see. Okay, so now I would like to get back to this idea of this simple test I've shown you before. And as I said, whenever we are running the main method, there is created the zone root object. And this is the main zone where every code will be performed. In case of testing, the responsibility of this zone will be to simulate the environment for tests, because first of all, we are running those tests in the processor of our own computer, not on the normal device. So we don't have the implementation of every single library. For example, we don't have the implementation of the Dart UI library. So it has to be some sort of mocked. Also, this zone will execute the code for reporting results, exceptions handling, and running all the callbacks, as you've seen before. So we had this test method, which runs the run zoned method. Yep. And this is exactly what happens here. So this callback, whenever it's created, this run zone method will create a small box, which will be disposed whenever the test ends. Those results will be just read, and that's it. The box will be disposed, and we don't have to care about it anymore, which is a great and powerful tool for that sake. Okay, so this is about this testing environment idea, which is quite clear and I think quite simple. And I would like to now start writing the very simple test, like the first test during this presentation. But before that, I would like to make a very quick brief up about the test-driven development idea, because I would like to make this test in this manner, and just to show you how it maybe work for you. So let's imagine the very briefly some sort of abstract situation that you are a developer and you got the ticket. So your project manager gives you, through some ticket tracker, maybe on Jira, the ticket with the functionality that you have to implement in your code. So you're reading this ticket, you're implementing it inside of your code, and after this, you're writing the tests that are checking if you've implemented it properly. But let's just imagine what will happen when the manual tester would like to test your code. He will also take the ticket, he will read it, and he will check if the content described inside of this ticket is implemented properly in your code. Running those automated tests that you've created will do pretty much exactly the same thing. Those tests will check if the content described inside of those tests are implemented properly inside of your code. So let's just summarize that. We have a ticket, that describes something that is written inside of your code, and you also have tests that are describing something that has to be implemented inside of your code. So can we just say that the content of the ticket and tests should be pretty much the same? Well, as we know, it's not usually that ideal because life is brutal, but usually the idea of test-driven development, this principle, is based on this very simple idea. And it's taking from the idea of preserving tests as some sort of documentation of what you have inside of your code, is basically the most important foundation for every other argument saying that distributed development is fun and probably interested to use. But this is like a very abstract idea, how we are implementing it actually. So this is the very common schema that I think everyone's seen at least once in their life. And whenever we were trying to do something in test-driven development, we were starting with the failing test. So the test that there's green, there's red, so it doesn't pass. Then we are implementing this functionality inside of our code, so the test turns green. And whenever we would like to change something, we're refactoring our code, we're starting with the failing test once more. But what it basically means is that we are starting with describing our requirements inside of our code. So whatever we got inside of our ticket, we are basically writing exactly the same thing in a programmatic way. To be honest, there are many tools that are making it much easier. If you are writing the ticket in a proper manner, you can basically use some very simple script, which will generate the content or the framework for the tests. Then, when you have this kind of those requirements, you're meant to meet those requirements inside of your code. So you're implementing it, and whenever those requirements changes, you're starting with describing a new one. And this sounds very good, very nice, but unfortunately, the reality is a bit different. And I've done this many times on Android, and believe me that between the failing test and the passing test, there's one more state, which is the situation where you're pretty sure that your production code is exactly what you want to have. But unfortunately, tests are still broken and are not working as expected because you have to know some tricks and tips inside of those tests. It doesn't work that obviously. So yeah, it's usually quite difficult. Like happily, I have to say that from my experiences in Flutter, the situation is a bit different. And you can really be, with some experience, sure enough that your tests are written exactly as it should be. And then it's not that difficult to really maintain this kind of a cycle, which is very nice and productive. Okay, so this is the moment for the demo I would like to cover. Do we have any questions at this moment, at this stage?
No.
Okay, so let's start with the very simple unit test, first of all. Can you see my screen right now? Everything goes as expected?
Yeah, very good.
This is this application that was prepared for you. So this is display screen, and I can type Copenhagen, and yeah, there's a city. I can see what it's 30 Celsius, 30 degrees of Celsius. Oh wow, I would love to live in Copenhagen right now. Okay, so the thing is that, as you can see, I can input some sort of a query here, but let's just assume that I can also put some strange numbers here, which are totally not as they should be. So let's just build a functionality of validating this query in a TDD manner. So how we are doing it? First of all, inside of maybe the util class, util folder, we would like to create a dot file, and we will call it query validator. Okay, so here we can create a class. Sorry. Query validator, in which we will have a very simple function, bool is query valid query. Okay, and for now, let's return true. Why not? Maybe that would be a little bit more readable. Okay, so we have a very simple framework for that. We didn't implement any production code yet. We just have some sort of framework of some sort of architecture that we would like to have inside of our code. Architecture is not tested, so we are definitely free to do that. And now inside of our unit test folder, we can create the file to create a test for this query validator. Query validator test. And here, as you've seen, we have to start with the entry point, which is the void main method. And inside, we can start building our test, which is nothing else but running the function test. with some sort of description. And let's just assume that we would like to see if that when query contains the numbers, this validator later will return false. Returns false, okay? And here we have our callback, as you've seen before. And inside here, we will implement our test. Of course, as you can see, we have this notification that is something wrong. And the idea is that we have to implement the test package. And this is the first from 2 packages that we basically need to have tests in our application. We are using this test dot only because the code that we are testing is purely Dart. There is nothing connected with Flutter itself. So we can definitely use this package here. And now everything goes as expected. So now we can just create a test with the given when done principle. So whenever we have the query validator, that's something that we have given. And we would like to see that whenever the validator will have to validate the query that contains some numbers, we would like to know that this result is expected in such situation. Oh, sorry. To be false. Yep. So this is a very simple idea. It's very obvious, straightforward. We just described our initial thoughts about this query validator. So whenever we will run this test here, we can see that it's actually not working as expected. It's definitely not doing what's meant to be. We can also create another test just to see if we are maybe contains special characters, maybe like @ or something like this. And we can see if a bunch of those tests, they are definitely not working as expected. Yep, so we have, right now we have 2 requirements that are strictly given to us by the ticket. And now there's a good time to start implementing the code. And of course, this could be very, very easy. We can see the query contains some regex. And yeah, this regular expression basically checks if we are using only letters. And yeah, we can test our check our tests right now, and everything should be fine. Yep. So the tests are now passing, and that's the very basic approach for the test-driven development. Do you have any kind of questions at this stage? Yeah, I think that was quite simple, so maybe not. So I would like.
That was a very good goosebump for me, that it actually is simple, and I didn't have to do too much to configure Dart or Flutter.
Yeah, that's a very good thing. Yeah. Mm. Okay, so I would like to just give you a few things for consideration, because as you can see, those tests doesn't look very good. Just imagine that creating this validator would be a little bit more complicated, for example, and basically we can run those tests like separately, but it's not very convenient. So basically what we can do right now is to make the code a little bit better. And to use that, we can use the groups, basically, which is nothing else but another method that has some sort of identifier. And this group has also the callback that will call another functions inside of it. And to understand the idea of these groups better, so it will work for you at every situation, is that the groups work pretty much exactly the same as tests, where tests are leaves of the tree of callbacks that you can create. So the groups can contain different groups and so on. And yeah, basically you will get like some sort of a tree where the leaves of this tree are tests. And inside of this group, which can just wrap some bunch of tests and additional functions to set up some stuff. You can use the setup function, tear down function. Those methods will be executed before and after each test inside of the group. And as you can see, the implementation once more, this is exactly this await run zone function that we've seen before. This is our callback. And as you can see, just before this callback, we have this run setups function, which will run every single setup that we have inside of this group registered. Also, in like the tear down, as you can see, is triggered before running the zone. So this is like also well good to know that we basically, because we are using this run zone thing, we don't have to actually be that curious about cleaning after every single test. The tear down function is mostly used for changing some properties of the grouped item. I will cover that maybe in the code. That will be probably a better example. So we can, as you've seen, create a group for our tests. Good. Okay. Do some formatting. And now what's very good about this thing is that we can run the whole group with the one click. And you will see in the results that we also have this nice and fun tree, which gives you the idea that, okay, now I'm testing the query validator. So I can also remove those unnecessary descriptions of the test and so on. But the thing is that we are also doing this given function here every once more, which is totally not necessary. So because we know that there is a setup function called every time before those tests, we can easily make the query validator field accessible for the every single test inside of the group, and just get rid of it. In this situation, this code will also work as expected, and we don't have to worry about that. For the further optimizations, I would like to point out that, this function will be performed before every single test, as you can see. So we will see two setups, okay? But maybe some further optimization if we have like very expensive object that is created very difficulty, and it's not changing its state in our test. We can perform the setup all function, which will be triggered only once. And that's basically the simple idea of how we can use those groups and maybe gain some advantage over that. Okay, so I'm running a little bit out of time, so I would like to start talking right now about mocking, which is also a very important thing when it comes to testing. So sticking once more to this idea of the windows and the walls, because it's quite, this is some sort of a basic concept for this presentation. Let's just assume that we have some sort of system like this, that we have a class window, which has a lot of different objects that the windows consists of, and the wall, which has the window. And we would like to have a test, which will basically test this function open window, which is changing the state of the wall, depending on the result given by the window itself. And this is the test that we would like to have. So we would like to test if we're opening the window on the wall. It basically was as expected. I'm giving you only this idea of works because we would like to see if different scenarios. If the window, for example, is broken, if the status propagated as correctly, and so on and so on. So what we are going to test is that we would like to see that when we are opening the window, we are expecting the wall to be open or not, depending on the situation of the window. And this is a little bit tricky situation here because we have to create a wall, and the window object is difficult to create because we have the frame, we have the glass, and so on, so on, so on. Just imagine that it's very difficult. So that's the first thing. And the second thing is that we have to also have some sort of control to know if the window will fail to open or will it succeed. Just imagine how difficult it will be to have like different objects doing some strange stuff. And so, trying to build some sort of constructor and building some strange constructions is probably not the good idea, and I'm definitely not recommending that. We can do it much easier using mocks. And as you can see, we can use Mockito, which is another dependency, like the second and the only one that we are also using for the Flutter. So we're using this dependency for testing with the Flutter test library and the Mockito, and that's pretty much everything that we need. And in such situation, we can create a class that will extend the mock, which is the object taken from this Mockito library, which implements the window. So basically this object, this mock window, will be nothing else but some sort of a dummy, which will look exactly the same as the mocked object. It's very easy to create and gives us the two very powerful tools. First of all, we can, in a very easy way, steer behavior of this object. So we can just say that whenever on this mocked window, there will be performed operation open, this operation will return, for example, true. And also we can check if some methods were performed on this object. So we would like to see here if this method inside of wall was actually running this open procedure. So it's not some sort of a failure. And this kind of approach is giving us a huge power to use. For the sake of demonstration, I wouldn't like to elaborate a lot about some architecture of this stuff. I would like to also only just present you some tests. But basically here we have, as you've seen, we are entering the query and we can get some sort of data. We're getting those data from, we are using the block architecture. I don't want to elaborate much about this thing because it's going to be, it's a presentation about tests. So for the sake of this presentation, I would like you to only think about the idea of a block like some sort of a black box, which gets the input, which is the query, and it's in some way performing the operation, which will produce from this input some sort of the output, which is the place suggestions in this such a situation. Okay, so let's just focus only on the idea of the search function, and as you can see, we have the line which is performing some sort of a method over the place repository. So we would like to get the place suggestions using the query that was provided by our user. So let's just see what this place repository is. It's some sort of an abstract class, some sort of an interface which will be override by different objects then. And so this is the perfect situation where we would like to be sure that inside of our test, there wouldn't be some sort of an object that will actually perform some HTTP calls. We would like it to return some static content that we're perfectly aware of and we have the full control of, because we are only unit testing our block. So in order to achieve that, I would like to show you the real life example. So this is the code I've shown you before. This is some sort of local mock place service or something called like that. It extends this mock and it implements the place repository. So inside of our setup method, we can create this black box, as we've said before, which will use this mock repository. And thanks to that, inside of our test, we can easily steer the behavior of this object. So we can tell that whenever this place suggestion method called here will appear, we will get some suggestions that we've created statically here, and we can expect them to be exactly as it is here. And this is a very powerful tool. So I will just run this test. It will work as it is right now. But I would like to also show you that whenever I, for example, change this query to something else, like query 2, this test wouldn't work because the query was different and the reaction was of this block was also different. So this is basically the idea of mocking, and this is the most important thing to know about unit tests, in my opinion. Do we have any questions regarding this mocking stuff?
Have some question. What we can do with mock when we need testing this use in this test the property of class which we now mocking.
I'm not sure if I understood you correctly. You're asking about properties, not functions.
So what he meant is basically if you have, let's say the item.loading, this is a value you wanted from the class. So the class has a value that gets set from your places. Yeah, so let's say that was country. Yeah, so you made a call to the places API, and that returns a country, and the country is mocked to Denmark. Yeah. So how would you set that in the mocking library?
Of course, like we can also return mocks as well. So it can be the object that is also mocked. So we can create, I'm not sure if I'm answering the question, but let's imagine that we have like a different object, which is also this place suggestions. And we can create an instance of this object. That's actually, it should be different. Yep. And I can definitely return that as well. So it won't complain. Yep. So this is the way where we can actually also return like mock object. We can also give some, of course, the place suggestion is a little bit easy, but we can change the behavior of this object as well. So we can create also some sort of, we're not obligated to, in return from the mock, only real values. We can return mocks from mocks as well. Is this answering your question?
Yes, thank you.
Okay.
Your answer.
Maybe I would ask if you have found a way to mock functions in a good way, because sometimes the code that you write would benefit from having top level functions, sort of like without objects, right? But you have to wrap those functions inside objects so that you can mock them. And if you have found some way to sort of like the best way to circumvent this.
By the way, hello, Mate.
Hey, Rafał, nice to meet you.
Nice to meet you as well. Well, world is small, you know.
Yeah.
So basically, this is a very good question, and I don't have an answer to that. You know, this like usually that's the problem when you're trying to make something a little bit out of you know, the mainstream and the framework, where the tools are a little bit helpless, and you have plenty of exactly the same situation with mocking static content in Android applications. That's also a huge pain. There's like a separate library for that called Power Mockito, which allows you to mock static fields, final fields, which are already created, because that's the problem when you are working with, for example, some constant values as well, which are assigned during the compilation of the code. You're basically helpless to change its value. You cannot do that. So you definitely have to use some workarounds. And this is a huge topic. I think that whenever you have the situation like that, you are basically having to, you know, just improvise maybe. But it usually happens when, no, that's the problem with using some sort of singleton patterns and global stuff inside of the code, because it doesn't give you the flexibility. So exactly. I don't have an answer, unfortunately, sorry.
No problem, at least I asked, thanks.
Yeah, that's actually, I think that's a Nobel Prize probably, for if there is some Nobel Prize for informatics. So.
All right, so I may try.
Okay, thank you very much. Actually, I have to probably go to another thing because I have like 2 minutes only. So the next thing is the promised widget tests that I've, that's a good idea, yeah, a little bit light. As I promised, I would like to cover the idea of widget tests. And as long as you're not sleeping, the thing is that we should be very excited to hear about that, because this is a very powerful tool. First of all, as you probably know, we are using widgets a lot inside of Flutter. And as they say, everything is a widget, which is a small lie, but basically from the developer perspective, the basic core of the API that we're using are widgets. So every screen, every part of the screen is a widget itself. And we're building those widgets. And they're using some different layers of the Flutter framework in order to communicate with the canvas, in order to draw something, or they're accepting some events from the framework as well. And they're doing it through the Flutter framework. So they're using, for example, the render objects and so on and so on. But the thing is that the Flutter team gave us a very powerful tool, which are widget tests, to treat the widget in some sort of an isolation. So instead, in this kind of environment, the widget, instead of communicating directly with the whole core of the framework, there are a few middlemen which are giving us some sort of simulated environment. So whenever widget is trying to draw something, there is a finder which is aware of those operations from the widget, and we can use it to basically know what's the current appearance of the widget currently on the, let's say, emulated screen. And we can also use the widget tester, which is the tool to basically interact with the widget in some sort of emulated way, of course, because we don't have those tests are not triggered on the real-time device, on the real emulator, on the real device, but they're working exactly the same as our unit tests. So they're just pretty much simulated, and that's nothing more complex. Those tests are very, very fast and very simple. So this is a great, powerful tool to imitate some functionalities of the UI tests, because we can be pretty much sure that whenever we test the widget with the widget tests, and we've checked that something, for example, started to animate or started to appear, it will definitely be there on the screen on the real device as well. So this is a pretty much great tool, and it's perfect fit for integration tests regarding the whole widgets. Also because widget tests allows us to build the widgets, which are the components built, they're like the Flutter objects from the Flutter world, not from Dot itself. And as probably you know, you are unable to create the state of a widget without the widget. So this kind of tests are also enabling you to test the code that you have inside of your state. So this is a very powerful tool, and definitely it's a must to be acknowledged with this kind of tests. And I would like to show you how those tests looks. They're a little bit different. There's also the second package for it, but basically this is the same package, but it's just split apart, so you don't have to take all those dependencies that you don't need. And inside of this package, you have the access to test widgets function, which has a little bit different appearance, because now this callback is first of all asynchronous, and it takes as an argument this widget tester thing that I've shown you here. So we have this interactor inside of every single callback that we're using. And the thing is that it has to be asynchronous, because the tester operates on asynchronous operations, which is like, for example, await, and those operations are handling the state of the widget as well. Because the thing is that this, as I said, this widget test environment is simulated one. So for example, automatic handle of a state of a widget doesn't work here at all. And we have to handle it ourselves. And that's why those pump widget functions are handy. And basically, there are three types of those functions. There's a pump widget function, pump, and pump and settle. And what those functions pretty much do is they're handling manually the state, or recreating the state of the widget. So whenever we're making the pump widget function, we are basically making the widget from not existing state to existing state. We also have the function pump, which is pretty much the equivalent. You can expect exactly the same thing, which you will do from set state inside of your code. But the thing is that you have a lot of set states, of course, in your widget that you're testing, but those set states are not taking immediate effect. The framework is like waiting for those pump methods in order to recreate the state. And this is a very important thing to know, that you're manually testing it, because it gives you a huge power to test whatever you want at the exact moment of the moment, at the moment where it has to be tested. So you have the full control over the behavior of the widget inside of your test. The third and the last method that you're using for the widget test is the pump and settle function, which is a very nice and handy thing, which just basically wraps the idea of the pump, and it's used usually when you have some sort of transitions, animations between different widgets. And this function will basically call the pump function as long as there are no scheduled frames in the builder. So it basically will wait after all animations ends. The thing that's very important, if you have some like pending infinite animations, like the circle, loading screens and so on, whenever you will run this method, it will just wait into eternity because there is always there is a scheduled frame. So you have to be a little bit careful with that. I'd like to show you those widget tests. I'm sorry. And for this sake, I would like to create a very simple widget test testing this small piece here, because the widget test can be used either for the whole integration of the whole screen or like the small pieces that we would like to be sure that they're working as expected. And as this is a little bit easier, I would like to start with that. So we have some sort of like a simple widget thing, which will probably make my life a bit easier. And we would like to, I'm sorry, I've opened the thing for you. So yeah, that's the implementation of this place item that you can see here. So it basically have the reference to the place model, which takes like some geometry, some properties, and so on. And yeah, you can see that we are using the hero tag. We are showing the text with the property place properties name, and like properties place type and the country. So that's basically it. So let's just test if our place item, whenever it's given the place, whenever it's created, it just displays this name. That's like very simple test. So we can start with widgets with a very simple description that the place item will places name. Okay, and here we have this callback with widget tester, which, as you remember, is asynchronous. And here we are able to write the test. First of all, I will create the I will create the mock place model, and I will just make a little bit scheme here because I have the nice and cheesy. So this is some sort of abracadabra here, but basically this is some sort of mocked response, so we don't have to recreate it here. So the code is a little bit more clear. And here we would like to start to build our test. So we would like to pump our widget. So we're creating it. Place item, and we are adding the place. Yeah. And let's see if this test will actually work. As you can see, there is a problem because I'm not sure if you're very familiar with this, but it basically says that I've built the widget, which is using some inkwell and another properties, but it's not bounded with the material widget, which is this material app, which gives the theme data, and so on, so on, so on. So it's a very important thing to understand right now that this framework treats us like adult people. So it doesn't, there is no shortcut here. It has to be done properly. So in order to test that, we have to basically wrap it in the material lab and scaffold if we're testing that small piece. I prepared like the helper function here. I'm going to use it here in order to make my life a bit easier, but still, as you can see, it's using this pump widget under the hood. And as you've seen, I'm just creating this simple object, and I can now expect to find a text, which will be, as you've seen, properties and the name. Yep. So that's exactly what we are expecting to see here. Yep. So this is a text, and we're expecting to see it here. And we are going to find exactly one widget. What I really like about this testing framework is that it really is very easy to read because you have a lot of those matchers. You can expect to find none or n the same widgets. You give it basically, you are given this basically for free. It comes directly from this test Flutter package. So you don't have to write them basically by themselves. And those tests are very easy to read. And whenever I'm running we'll run this test, it will basically work. I assume, yeah. Okay, so it works. Of course, we can add another, the more difficult things and so on and so on. Those widget tests are also meant to be like the implementation tests. So this is the test for the whole screen, as you can see here. I am setting up like the blocks, this repository. This is the thing that I'm showing you before. I'm creating this screen object, which is taking this block. I can have like different interactions, like for example, enter the text to the query field, as you can see here. I can then, pump and settle in order to check, to wait after all animation ends and expect to find something. As you can see, this kind of syntax is very, very easy because you can basically just, enter the text and that's it. You don't have to build some sort of strange constructions that you have to click on it first and anything else. It's given you basically for free, which is a great and very fun stuff to do. Okay, I would like to ask you if you have any questions regarding this widget test, because there's like last thing about the UI tests. Yeah, and I have like 5 minutes left. So do we have any questions regarding this unit test?
One question: when we use find, which properties we can find widget only by type?
Well, that's a very good question. Basically, I've just made it very, very simple, but the finder has multiple different possibilities to use. We can actually search for the text inside of our widget. We can search by type of widget if we're expecting it to be only one, by icon and so on. But the most important and commonly used thing, if we have like very complex screens, where we would, for example, have multiple text types, and it's a key. So basically, we can add the key to our widget inside of the speaker screen. So for example, here, I could add the property key. Some, for example, global key, just to be sure. And yeah, that's it. And I can then search for this key in the Finder, which is also very nice and comfy way. But basically speaking, there's a lot of stuff like this. You can check by the type of the widget, descendants as well. You can find descendants inside of the widget that you found, which is, yeah, it's a very powerful tool. And I think that, honestly, I didn't have the problem that I didn't have the Finder I needed.
Okay, thank you.
Any other questions, maybe? Okay, so I think that we don't have questions. So let's go to the last part. It's going to be a little bit definitely quicker and shorter, as the thing is that UI tests are not usually meant to be done by developers themselves. Usually there are QA teams that are doing that. And also the thing is that the UI tests in Flutter are not that great as the rest of the tests I've shown you. Honestly, there are some problems with the Flutter driver currently, as far as I know. So yeah, it's maybe not that great, but still it's a very powerful tool regarding few key scenarios that I would like to show you. And basically what the UI tests are is that you are creating basically the same application that you will give to your users, but this application will accept interface, which will be the scripts from the Flutter driver tool. And this is exactly how it will look like here. So we are creating the main method. I'm sorry, the main method. This is the entry point that we will have in our application, like another entry point. As you can see, it's exactly the same that we will have like for a normal application where we are executing this run app function. But instead, we are here also adding this enable Flutter driver extension and this package, of course. It basically means that from this point now on, the application run by this entry point will allow to connect by the Flutter driver and will accept events sent from them, from those scripts. To run those tests, you are basically you can run the console calling the Flutter driver and setting the target for this function where you have this main method. And I'll just give you a brief idea how it works when I'll show you the code. But basically, the idea to maybe have a better approach to see how it works is that inside of our code for the script for the Flutter driver will look pretty much familiar to what we had before. So we also have those tests, we have those groups, but so it also operates on the same principle as those unit tests. It's basically exactly the same thing. But here we are using this tool called Flutter driver, as I said before. We're setting it up, which basically means that we're connecting the Flutter driver to the application on our emulator or device. And yeah, after this, we have to, of course, tear it down, but it's like quite an obvious thing. And then we are able to write a test. And those tests are a little bit different. It's quite familiar to what we've seen on the widget tests, but instead of this finder and the tester, we have a driver. And as you can see, those constructions are a little bit difficult, more difficult, because this test here is basically to enter the query to our the text field. Yeah. So first we have to tap on it. Then using the soft key, we have to enter the text. And of course, we should also wait after every frame is ended. So that's basically how it looks like in the test. Okay, but the thing is that those tests are maybe, as you can see, it's probably easier to do such a simple interactions and widget tests. But the UI tests have a very good property that I would like to highlight here. So as we know, they are triggered on the physical device. This is exactly the same application that we'll give to our customers. So it's a perfect tool to measure key important factors. In order to do that, we can basically wrap up some sort of, some operations, some test with this trace action function, which will calculate the timeline of each and every action performed and the behavior of the application. And then we are able to calculate some sort of a summary, some sort of a report from this timeline. And this timeline will give us the possibility to, for example, check if the worst frame build time didn't exceed some sort of value, because we would like to check if we don't have any kind of junk code. And this is great, and we can achieve that in our widget tests because they're not performed on physical device and they don't have everything as expected. So this is a perfect use case for the UI tests, and that's why it's worth to use them. This is time for a quick demo. And this is inside of the application, whenever you will be interested to see that. This is this place list inside of this test driver package. I have my place list dot file. In here, I have my main application, which has exactly the same thing I had. Yeah, so it's enable Flutter driver and run application. It's exactly the same thing that we can see here. This is the same line. But as you probably see, I'm using also some the dependency injection. I don't want to be like a lot talking right now about DI because it's a different topic. But just to give you a quick example, this tool will basically inject, instead of those abstract classes, it will give you the proper objects. So it's a very good thing to use that here for the UI test, because we would like to also avoid direct calls to HTTP, for example. So as you can see, whenever I'm asking for the weather repository, I'm returning something that is pretty much mock. So it has some static data. And this is a very nice and easy trick to avoid HTTP calls basically in your code. And yeah, so this is the main function I've described. And as you can see, this place list has also like the similar file, which has the suffix test. Okay, and this is exactly where we have this script for our Flutter test. And this is the exact way how this should be done. And as I've shown you before, in order to run it, we can simply input the command Flutter driver. Then we are setting the target that will equal the destination of the entry point for this test. Okay, so this is the thing here. This is the entry point where we would like to trigger the application. So Flutter driver will be basically notified that it should connect or trigger this application from this entry point. And in order to perform the script, it will look for the similar file with the suffix test. So this is some sort of a convention that we have to be aware of. So whenever we will run this test, it will build the application, trigger it on the physical device, on the emulated device, and we can see if this test, the very simple test that is basically doing inputting the query and waiting for the transactions, and then checks if we have those 3 mocked properties displayed on the screen, and also it checks if we tap on the element, like one of those elements, like the first one, if it opens the detail. So this is a like very simple wandering test It's not pretty, of course. I'm sorry that the code is quite ugly, but that's only for the testing purposes. And it's good to see all the code in one place to understand it better. Okay, so the code build up, and as you can see, I've entered the ASD. I've clicked on the first item, and okay, it worked. Okay, so and yeah, I've got an error here, so I'm wondering what was the problem. That's strange. So I will definitely run it once more. You know how it is, reboot until it's good. But the thing is that basically it should work without any problems. And then I would like to show you that we can just assume that it worked and there is no problems with the physical devices as is usually during the live codings. But then we can just assume that, for example, we have this very, very demanding customer who would like to see his code working on a very, very strange rate that the average time is less than 5. And okay, I don't know what's the problem. Oh, I see. That's probably I've changed something inside of the code. Okay, so I have to apologize you that probably I've missed something else. Yeah, something maybe here. But nevertheless, let's just assume that whenever I will, for example, change this thing to lesser value, this expect will basically make this test a failure, so it won't work. And we will get the information at the end of the day. For example, we will have this UI test suite placed inside of our CI pipeline as well. That okay, during this work day, the code that we've committed to the repository was causing some issues with the performance of the application. Okay, so that's pretty much it. I would like to hear if you have any kind of questions regarding this UI test and basically every other test, as this is the end of my presentation. I would like to thank you very much.